Good morning and happy Friday. I will be back with you on Monday and I'm looking forward to being back. So for today, we're going to finish up with some of our trig functions. Would like you to grab a half sheet from the front counter if you haven't already and explain what you know or understand about the even and odd functions that we talked about yesterday. Also, if you have any questions about even and odd functions, would you write those down, please? Pause the video here so you can take care of that. Okay, I'd like you to hand those in and collect those for me and so that I can look at them on Monday and kind of see what kind of questions we still have. Remember that there will be a PC on Tuesday over all of these things. All right, with your side partner, I would like you to see about writing all the trig functions in terms of sine and cosine. Everything in terms of sine and cosine. So pause it here so that you can write these in terms of sine and cosine. Okay, so sine of theta, obviously, is in terms of itself. Cosine of theta is in terms of itself. What did we say that the tangent of theta could be written as? Right, tangent of theta is sine over cosine. Cosecant of theta is 1 over the sine of theta. Secant of theta is 1 over the cosine of theta. And cotangent of theta is the reciprocal of tangent of theta, so it is cosine of theta over sine of theta. We're going to use those today to come up with some trig identities and use those for some problems. All right, so I want you to think about writing the Pythagorean theorem in terms of sine and cosine. I'd like you to pause it here a minute. I'd like you to work with your side partner. I'd like you to think about drawing a triangle. We have a point on the unit circle, some point x, y. Unit circle, so the radius is 1. I'd like you to think about writing the Pythagorean theorem for that triangle, and then I'd like you to think about putting that in terms of sine and cosine. Pause it here so you can do that. Okay, would you and your side partner share with the group in front of you or the group behind you? And compare, please. Okay, what did you get? So we know that this is x. We know that this is y. We know that we have a right triangle. So the Pythagorean theorem says x squared plus y squared equals our hypotenuse squared, or 1 squared. So x squared plus y squared equals 1. But on a unit circle, what do we know that x is, and what do we know that y is? Right, x is the cosine of theta, and y is the sine of theta. So now think about it. If you haven't already done it, what could you do? All right, who would like to share? Right, x is cosine of theta, so x squared is cosine of theta squared. Y is sine of theta, so y squared is sine of theta squared. Oops. I'm going to write it like this first off. Cosine of theta squared is often written like this. Cosine squared of theta plus sine squared of theta equals 1. That is a key trig identity that you need to know. You will need to memorize that trig identity. Okay, this trig identity is a key trig identity. There are two other key trig identities that you will also need to know, but they can be derived or gotten from this one. I will tell you what those two are. I want you to come up with how to get those. So one of them is 1 plus tangent squared of theta equals secant squared of theta, and 1 is cotangent squared of theta plus 1 equals cosecant squared of theta. These are our three key trig identities. These two identities come from this one. So I want you to take a minute, I want you to work with your side partner. I want you to see if you can figure out what can I do to this one. So I'm going to just write it here. We read this cosine squared of theta. It is the same thing as cosine of theta squared. It's just kind of the notation that we use. I'm going to write it over here again too. From this main trig identity, can you get these other two? So we're going to pause it here. You're going to work with your side partner. You're going to take about 3 to 5 minutes. You're going to see what you can do to come up with, and then you're going to pick one of these that you think you figured out, and you and your side partner are going to put your solution on the board. So pause it here, work with your side partner for a few minutes, see what you've got. Okay, so now I want Coach Gaines to find some group that has done it correctly and have them explain it to the class. Great, thanks so much for helping. So what did we do here? We divided this by cosine squared of theta. But if we do something to one thing, to keep it equal, we have to do it to everything. So it means we have to divide everything by cosine squared of theta. So cosine squared of theta divided by cosine squared of theta, that's 1. Sine squared theta divided by cosine squared of theta, that's tangent squared of theta. 1 over cosine squared of theta is secant squared of theta. And then we can do the same thing on this side to get to this one, but instead of dividing by cosine squared, we've got sine squared of theta that we're dividing everything by. Cosine squared over sine squared is cotangent squared. Sine squared over sine squared is 1. 1 over sine squared is cosecant squared. These three trig identities are going to come in handy, as are these trig values, because we can look at some problems like this. We have the tangent of 20 degrees minus the sine of 20 degrees over the cosine of 20 degrees. So I have the tangent of 20 degrees minus the sine of 20 degrees divided by the cosine of 20 degrees. Doesn't involve any squared terms. Our angles are the same. That is a key piece. Our angles have to be the same for our trig identities to work, for any of those three trig identities to work, or for any of those to work. So what is a substitution that you can make? Well, sine over cosine is the same thing as tangent. So I have the tangent of 20 degrees minus the tangent of 20 degrees. And we're going to do this without a calculator. Well, what is the tangent of 20 degrees minus tangent of 20 degrees? I don't know what it is, but when I subtract two equal things, I get 0, don't I? If I have sine squared of pi over 12 plus 1 over the secant squared of pi over 12, what do I have? Sine squared of pi over 12, this is my angle. Is this the same angle? Yes. Can I rewrite this in terms of anything? When I see the squared, I should be asking myself, is there any trig identity that I could use? It so happens that there is. Sine squared plus cosine squared is 1, but what is 1 over secant squared? It's cosine squared. So I have sine squared of pi over 12 plus cosine squared of pi over 12. What does that equal? Well, sine squared of an angle plus cosine squared of the same angle is equal to 1. So that's my answer. This is my answer here. Now, let's think back to these trig identities here. We might not always see them in this format. We might see them in some manipulated format. For example, what if I see something like this? Cosecant squared of 42 degrees minus cotangent squared of 42 degrees. That is not one of those trig identities exactly, but can we do any manipulation with that? Take a look at this one. It involves cosecant and cotangent. So it must be something along those lines. Okay, talk with your side partner about that. Is there anything you can do to this trig identity to get it to look like that? Pause it here, talk to your side partner, see what you can come up with. All right, so we started with this cotangent squared of theta. In this case, our theta happens to be 42 degrees. So cotangent squared of 42 degrees plus 1 equals cosecant squared of 42 degrees. What can I do to this to make it look like this? Well, if I subtract the cotangent squared of 42 degrees from both sides, I get that 1 is equal to the cosecant squared of 42 degrees minus the cotangent squared of 42 degrees. That's what I have here. What does that equal to? It equals 1. You're not going to see a lot of variation in answers, but you're going to see a lot of variation in terms of the problems. Okay. What if I had something like this? The sine of 30 degrees over the cosine of negative 330 degrees. Is there any way to rewrite that? Well, let's think about that. Where is negative 330 degrees? There is negative 330 degrees, but that gives me a 30-degree reference angle. So I have the sine of 30 degrees over the cosine of 30 degrees, and that is equal to the tangent of 30 degrees. So if they are not the same angle, we have to get them or manipulate them in some way or rewrite them in some way so that they are the same angle if we can. Now, it just so happens that we do know what the tangent of 30 degrees is. Tangent of 30 degrees is y over x. My y-coordinate for this is 1/2. My x-coordinate is square root of 3 over 2. So it ends up being 1 over the square root of 3. And if we rationalize, that ends up being the square root of 3 over 3. All right. So for Monday, I'd like you to try these problems. Page 134, numbers 77 to 90, all of them. I realize some of those are evens, but I would like you to try them all. We will talk about these and any other questions that you have on Monday when I'm back. Have a great weekend. Bye.